Today we're starting off the first day of notes with 1.9 trig functions. So it's really just a review to kind of highlight the main things from trig you should be very comfortable with off the top of your head. I'm going to do some of the problems with you and then leave some of them for you to complete for homework. So let's take a look at the warm-up. You're going to graph the function and identify period and amplitude. I will do part A with you guys. Looking at this function, the amplitude is in front of sine, so it's going to be 5, which means I'm going to scale my y-axis. So I'll go up 5, 1, 2, 3, 4, 5. I'll go down 5, 1, 2, 3, 4, 5. The midline is going to still be at 0 because there is no plus k anywhere on there, so I can draw that in if I want, or you don't need to. And then the other thing that's tricky is, identifying the period. We see that the b value is 1/2. The period is 2 pi over b. So when you simplify that, that should come out to a 4 pi. So our period overall for this function is 4 pi. And what I like to do with that is I like to scale this. So I like to go, here's 1, 2, 3, 4, and I'm going to call that 4 pi. And I like to go backwards, 1, 2, 3, 4, and I'm going to call that negative 4 pi. Now to make this graph, I'm doing a negative sine graph, negative sine. Sine always starts at the origin, essentially. It's not moved up or down, left or right. So this is still going to start at the origin. Sine goes up first, so negative sine will go down first. So I go 1 tick mark forward and I'm down at the minimum, another tick mark forward, I'm on the midline, another tick mark forward, I'm at the maximum, and another tick mark forward and I'm on the midline again. And that's just me applying the pattern of negative sine. And I can work this backwards as well to get the rest of this. And I'm just going to go ahead and graph this function. Now, part B will have some other information. We'll leave that for you guys to try later. We're going to go ahead and skip to example 1 now. Taking a look at example 1, we've got a little word problem here, and we're going to find a sinusoidal formula in this problem. So they tell us that on this date, high tide in Boston happens at midnight, and the water level at high tide was 9.9 feet. So that's going to be my max value. They also tell us that low tide was 0.1 feet. So that's going to be my minimum value. So if I'm trying to imagine what this looks like graphically, the max is going to be up here at 9.9. The minimum is going to be down here at 0.1, which means the perfect middle between these should be right at 5. So I'm expecting my midline to be at y equals 5, just because that is perfectly in the middle. And I'm expecting my amplitude to be 4.9, because that is how high up I go from 5 and how far down I go from 5. I can find that value by doing 9.9 minus 0.1 and dividing by 2. So I can take the difference of those and then half it. So 9.8, if you cut that in half, will give you that 4.9 amplitude that you need. So once I have that information, I want to take a look at the rest of the problem. They say that the next high tide is exactly noon. So high tide was at midnight. So we're going to call that, like 0 hours or something. And then the next high tide is at exactly 12 noon. So I'm at high tide again at noon, which would be 12 hours later. So I start at high tide, I go down, and then I hit high tide again. And so it's going to look something like this, which to me looks like the shape of a positive cosine graph. So I'm going to be using a positive cosine graph in my work here. So let's start plugging in what we know to this. We've got a y equals function. The amplitude is 4.9. It's a positive cosine graph. And then we know that at the end, we're going to have a plus 5 because of the midline, which is at y equals 5. Now, the other thing we need to figure out is our b value. So let's look at the period of this. One whole period right here is 12 hours. So if the period is 12, then that's the same thing as doing 2 pi over b is 12. Solve for b, and you should get pi over 6. So we're going to put a pi over 6 times our input variable in here. And that's how we get our equation for this. Again, there's another one for you guys to practice, and we'll move on to example 3. Now, in example 3, I'm not going to go through all of these with you guys. I'm going to leave some for you guys to review. But I'll do 4 with you because I think that's probably the hardest one. Now, we should be really familiar with, taking any angle and recognizing what quadrant it's in and, whether sine, cos, or tan will be positive or negative. But, it's always a little weird when you have radians. Part B, this is in radians because it doesn't have a degree symbol. It's always weird when it's in radians, but it's not in terms of pi. So I'll do this one with you. Let's think about the angle 4 radians. My angle is 4 radians. So I'm used to thinking of these in terms of pi, where this would be pi and this would be 2 pi. And pi as a number is 3.14 and 2 pi is 6.28. So 3 pi over 2 is, I don't know, something between that. But I think it's definitely going to be bigger than 4. So even though I don't have a calculator handy and I don't know what that value is, I know it's going to be bigger than 4 because it's halfway between 3.14 and 6.28. So that means my angle 4 is somewhere in here. Now, I don't know if it's closer to the X or the Y, and you might have an idea, and that's fine if you do. But if you just draw it generically, that's okay too. I know I kind of drew it like a 45-degree split, which it's not, but that's okay. Now, we want to identify the reference angle. The reference angle would be this little angle in here. And if I wanted to find that angle, what I would do is I would calculate 4 minus pi. If I took 4 and I subtracted pi, that would be that angle. And since I don't have a calculator, I'm just going to call my reference angle 4 minus pi. So that's actually going to be my answer for this. Since I am in quadrant 3, based on all students take calculus, tangent should be positive and everybody else should be negative. So for our problem, we have tangent being positive, but both sine and cosine are going to be negative values. I also want to do one problem from example 4 with you. So far we've seen, making a graph given a function, a word problem, giving the function for that as well. So let's look at, given the graph, how we reverse that to write the formula for the equation. So looking at this example for part A, let's identify what we can off the graph. It looks like our midline is right here at 0. So there's no weird plus k or anything. The amplitude is how far up or down I go from there. So our amplitude is going to be 8. And then the period looks like it's 20 pi because I start at 0 at my minimum and I hit 20 pi at my minimum again. If the period is 20 pi, the period is 2 pi over b, so you can set that equal. But you can also find b by doing 2 pi over the period and reducing that. And that should give you 1/10 for your B value. So it's always a little tricky to find that one. And then the last thing you want to do is identify what type of graph this is. It looks to me like a negative cosine graph in that it's starting at the bottom, going up to the top and back down to the bottom. So we're going to write this as negative 8 times cosine of 1/10 x, or I'll put x over 10. Again, I'll save part B for you guys to do, and we'll do one more problem together. And to recap our review of trig, the last problem I want to work out with you is one of my favorite concepts in trig is solving equations. There's all different types of solving strategies, and each of these problems kind of uses a different one, so it'd be good to review all of them. But in part A, I'll go ahead and do that with you. I think this is one of the more challenging ones. You start by getting sine by itself, which is of course not bad. You divide the 4 to get a negative 1/2. And you find where sine is equal to negative 1/2, and hopefully you know that happens in both quadrants 3 and 4. Go ahead in the Edpuzzle and tell me what these two angles are. Once you identify those angles to be, let's see, that sine inverse of negative 1/2, 7 pi over 6 and 11 pi over 6, then all there is to do is divide by 3. That's all that's left. However, because this is a 3x, when you have this situation, that's actually going to triple your number of answers. So what I like to do is I like to identify this as 7 pi over 6 and its coterminals. If I add 2 pi to that, I'm thinking of it as 12 pi over 6, I'll get 19 pi over 6, and I'll also get 31 pi over 6. So 7 pi over 6 is the same as 19 pi over 6, it's coterminal to that, and also 31 pi over 6. Similarly, 11 pi over 6, when you get coterminals to that, are going to be the same as 23 pi over 6, and then also 35 pi over 6. Now that I have 3 rounds of answer, my original round go around the unit circle, my second round around the unit circle, and then a third, now I'm going to divide everybody by 3, and that'll get me my 6 solutions. So these solutions should look like 7 pi over 18, 11 pi over 18, etc. 19 pi over 18, 23 pi over 18, 31 pi over 18, and finally 35 pi over 18, bringing all of my answers to values that are still between 0 and 2 pi, because even my biggest one is still less than 2 pi, so they all fit in my restrictions. Again, all these problems that I did not do will be part of your homework tonight, so please review those and make sure you're totally on top of that. Any questions, let your teacher know.